Hello. I don't know if you can see. I'm just going to post the link on Facebook. Give me a sec. Right, let me just get the link up myself. Hey, Retro Robbins. Afternoon, Adrian. Anyone else here? Hey, Gamer Eyes. Tony Dang. Glad someone's on the ball, Tony. Right. Let's start off. Hey, Matt. Thanks for the update. I shall give it a run. There. Out water. Retro Robbins. Enjoy your cup of tea. Hi, Richard. Right. Here we go. Everyone, afternoon, Stuart. Everyone up and ready? Ready for continuing on last week's, or anyone need to set up? I'm good, thanks, Gamer Eyes. You all are too. Helps if I'm typing on the right window. No, not this time. I didn't want to risk it just yet. I'll do it next week. Well, not next week, the week after. Because we'll be Christmasing, doing Christmassy stuff next weekend. Right. Load plot test not asm.ods. Right, and F10 to put it in game mode. F10 it again, back, so I can use case keys to scroll around. Right, we had that issue last week, which, hang on, this is the fix for it. And I shall get rid of that. That should be what you had last week. And actually, in fact, what I will do is I'll put it in DMA sprites. So if we go down to DMA sprites, actually, yeah, we'll go down to DMA sprites. In DMA sprites, which is here where it does the next reg, SPR select reg, comma A. What we'll do is actually, because we need to set the BC register with string, yeah, 303B. I'll explain this after. Just for a minute, I'm just going to out bracket C, comma A. And what that does is that sets the sprite, that image that you're going to be writing to, is set by that. Now there is a register lock which will lock the next registers to the same as the 303B, so that we can do the where is it? Scroll up again. So we can do that. Just do that. Next reg sprite select reg, 0, and that'll do it for both the image that you're going to write to and the sprite information that you're going to write to. But we won't do that for the moment. We'll just show you the way we were doing it before. Right, so we're on the DMA. Right, this line can go because we no longer need that, because that is done by this, because we're writing to sprite registers. Right, let me just make sure that this runs. Right, so if we save this, which is Control Shift or extend mode and S. Extend mode if you're working on a the latest only differs from last week's by having DEFS, define like storage or space or whatever, however you want to describe it. Derivatives or DS, as it takes less characters when you're typing it in. Right, yeah, let's just exit out of that, assemble it, and run. And now we have our sprite working. Right, now what I need to do is escape out of that, and then dot my SPR. Right, now this is our sprite. I'm just going to put a black if I use the right mouse button to pick up the ink color. Right, I'm just going to put a black outline around it, although it would probably be better with a white outline actually, wouldn't it? Done it again. Right mouse button to pick up. And I can't be bothered like moving the whole image across, so we'll leave the left hand and the top pixel blank. Right, we'll save that. So we've done everything that we did in the last one. And exit, and then if we now go back into .odin and then load our program again, plot test .ods, assemble it, and just run it. We now have our new sprite, and the sprite is still active even though we've been in the sprite editor which has done stuff. Now you may notice an issue. Hey Simon Bamber, no worries about being late. We've not done too much, but I will show you what we have done. I've just put an outline on the sprite, as you can see here. Put a little outline around it, a little white outline in Sprite Edit, but you don't need to do that. It's just for, showing that we're actually going into Sprite Editor, so that we were repeating the process, how to get the bug that we had last week. And yeah, no, yes, yeah, I suppose you could do Matt, but I'll do it as well for the. What I would suggest you do, Matt, is when you exit, pause, leave the screen sort of as it is, and pause the screen, and then once you've pressed a button or pressed a key, then return back to your debug screen with the registers and everything. And the reason, and turn sprites off, that would be super helpful for showing things when we're drawing things on the screen. Right, Simon Bamber, are you set up, and have you got Odin loaded and Plot Pixel? The pixel test.ods. Let me know if you're up and ready, and I'll show you what we did just before you got here. Yeah, you ready? Right, okay, cool. Right, scroll down to the DMA sprites. There was an extra instruction here that we deleted, which is Control Shift and X, or if you're on a real next, it's extended mode and X, and that will delete that line. And then, sorry, come down 2 lines, and then on this line, and press Enter, and then type in the load BC, string 303B, and out C, A. And what it is the when you're writing data to the sprite image data, you set the sprite that you want to write to in 303B. Well, in the port 303B. This was later. There was an addition later that came, which allows you to join the 303B register and the next register together. So when you change one of them, it changes both. And the reason for that was so you could just do the next reg when you're setting the image as well, which is what we normally, what I use now when doing the stuff anyway, when making games. And I totally forgot that last week that it was I forgot to add the bit to join the 2 ports, lock the 2 ports together. So anyway, so if you then, have you typed them 2 lines in? In the game loop, original code, where you had it set back to, right, which one is that? What, this one? No, we need the, yeah. Well, we need to do them to enable extra bits. Hang on, let me just check if it's in, if it was, see with, yeah, sorry, I put it in add sprite routine or C0, which forces the visible and the enable attribute for, because we write all 5 attributes. Well, attribute 4 being the 5th attribute because you start at 0. Right, anyway. Are we up to date? Oh yeah, I'll add the turn sprites off on my. Well, we'll do that now, because otherwise it'll stay on. Right, if you go up to the load y post comma 8 and then put semicolon end of game loop check actually, and then we'll do space, then check for space to exit, and then we'll change that to jump NZ, because we don't want to ret, we want to turn the sprites off. So we're doing the jump NZ loop because the ret Z would just return if it's 0, and if it's not 0, it'll jump back to loop. So we put the jump not 0 back to loop here, which I'll go through in a sec. Right, so we can get rid of these 2 lines. Right, and turn back to Odin. Right. We want nreg SPR. Actually, what did we call it? Select reg 0. Select reg, comma 0, and then we want to load b, comma 128, and then actually we can call this even. We can call this sprites off, SPR off, SPR underscore off even, and nreg. I'm doing this because I like putting things on the same line, and I don't think you can bring source from one line to another. And then go down and get rid of that line. Right. S off loop, and then nreg SPR, and then it will be pattern reg, yeah. Pattern underscore reg. Now we want to do the inc one on this because we're going to just set in one value for the whole of the sprite, just 0, and that will clear the bit 7, which turns the sprite on. So basically we're turning the sprite off, and then increment to the going to the next sprite, and then just DJ NZ and S underscore off loop. Glad you're enjoying it, Gamer Eyes. Right, and then follow it with the ret. Now we should be able to save that, and then A, and then run. Now when I press space, the sprites have turned off. Right, everyone following that so far? Come on. Right, everyone following it so far? Yeah, okay, cool. Right, the equates, does everybody understand how the equates work for the next registers? Just the fact that we're setting equates. Yep. And what I want to do is go through this and then start adding some comments. Right, set CPU speed to 3. Why is that? Oh yeah, 0.5 megahertz. Virtual SD just crashed. Oh, hold on. Right. I'll tell you what I'll do. I will grab the file that I've got now. Test.ods. Copy that back, and then File Explorer. Next. Right. That's today's date and time. That's the one. Copy. I shall put it on. I don't know if I can add it to. I'll put it on Facebook. On the file. Actually, I can't do that, can I? I'll put it in files. Upload file. Let's go and find this thing again. Hold on, bear with me. Test.ods. Starting test.ods file. Is added 303B. Okay, I'll just send it to is that not going? No, do I have to zip it? Hold on, let me just zip it. Change the zip to PIS because Facebook doesn't like anything. Why is that not sending? Let me just refresh Facebook. It's not letting me send a file. Right, the file is in the Facebook file, or the Spectrum Next Facebook files. Why the hell is it not letting me send a file? Because it's being fussy, you can't drag and drop now, you have to actually attach and then send. Right, okay. Matt, you should have the file to then give to him. Right. Yeah, I've posted it to you, Matt, so you can put it on Discord and send to Adrian as well. Hello, Pep Sanchez in Mallorca, Elas Baleares, Spain. He's pronounced totally wrong, but sorry if it is. Yeah, stick it on Jim's tutorials bit. Thank you, Matt. Quality poor text. Oh. The text quality is bad for the video. Okay. It should be fairly readable if you're watching it tomorrow, or download it. What I'll do is I'll grab it and post the video onto the group. Hey guys. I'm glad it's okay for you, Stuart. Maybe it's just the fact that he's in another country. I don't know. Anyway, hopefully it'll sort itself out for him. If not, I'll post a video. I'll download the video and then post it so you can grab it. I'll probably grab the others as well. Actually, if you just go to my Facebook, YouTube videos, they'll be live there, and you can just download them from there. Gaz Marshall, what have we done? Just turn my touchpad off. Right, we have made a change to the DMA sprites. We had a next reg here after DMA sprites, and we deleted that line and then added a load BC, string 303B here and out to bracket C, A. And that sets the sprite image data. The sprite image data gets sent to the value, well, the sprite image that you're output into that port. And there's, well, it was a while ago now, but which is why I didn't realize that was the problem last week. Where what you can do now is you can lock the two ports together. So the next reg SPR underscore I've forgotten the name of the bloody thing. Hold on. SPR underscore select reg, comma 0. That when you link the ports, that when you write to that port, it sets the 303B port to that value as well. And then that way, because when you're using the just the next reg sprite select, it just does for the for when you're actually sending the data to the actual sprite, not for the image, but the actual values for the registers, like the X position, the Y position, and everything. But we'll go into the bit for locking it in a sec. Well, after we've done this video, if we've still got time. What is the quality set to? What's the resolution set to for you guys? I don't know if I can set it here actually, because I'm streaming off a 4K screen, so but it's compressed down to 1080. Yeah, should be 1080 60. Yeah. It's mad to think that these pixels are probably the size of an actual character on a specky. Pixels are probably 8x8. Right. Mine says 480, but you can see and read clearly. Okay, cool. Just up yours, it was 720. This one should. Hope you can see me a lot better now. Hey. Right. HMER or ME7. I don't know if you're typing something or whatever, but I've got a load of dots appearing on the screen. If you've typed something, it's not come through yet, but unless you posted a pic or something, I don't know. I will scroll back again later, see if it's updated. If not, you might have to retype whatever it is you've typed. So just the 2 lines to add. Yeah. Oh, yeah. There's more to add. Let me show you. In our game loop, after the load a comma d, load y pos comma a, I've added a comment end of game loop, and then added a comment for check for space to exit, and then instead of we had ret z here, if you change it to jump nz comma loop, then and delete the jump loop after it, then that will, if space isn't pressed, it'll go back to loop. If the space is pressed, then it will fall into this routine, right, which is return back to Odin, but it's the routine, we've called the routine SPR off because it turns the sprites off, because otherwise it will leave the sprite on when you go back to Odin. So basically set the nreg select register to 0, and then load b, 128 because you have 128 sprites, and then a little loop, sprite off loop, next reg spr underscore pan underscore reg underscore inc, 0. That will turn the sprite off and increase the index, so you put the next time you write to a sprite register, it will be the next sprite, and then djnz will loop around 128 times because that's what's in the B register, and then return, which will return back to Odin. The out C comma A, yeah. Where was the out C comma A? Yeah, you got them 2 lines. Have you added them 2, Gaz? in here in the DMA sprites. Glad you're back on track, Adrian. DMA sprites added. Excellent. Right, so you now need to add the bit at the end of the game loop. Which is after the bit 0, A. There's a JPNZ loop instead of retz. Yep, you've done that one. And then you need to add the SPR off, which turns all 128 sprites off, even though we're not using all 128 at the moment, we're just using one. Let me know when you've added them, guys. It's just these 5 lines. SPR off, next reg sprite SPR select reg 0, and then load B, 128, and then S underscore off loop, nreg SPR underscore pattern underscore reg underscore inc, 0, and then DGNZ S underscore off loop, and then ret. And then you should be back to where we are. You ready? You ready, guys? So we can continue. Or is this not updating? The last message I've got is and JPNZ, loop. Just after DMA sprites added from Gaz. Has anyone said anything else? Because I do not know. Oh, you're done. Okay, cool. That was the last message. Thankfully, we're all up to date now. Right, so now that everyone's up to date, save it. If I press on the right screen, right, which is Control Shift and S or Extend Mode S. If you're on the real next, then Edit or Shift 1, assuming you're in the game mode keys, and then Assemble. Just remember, you might want to reverse the changes to the next reg. It doesn't in the Setup Sprites section. Where are we? What was the values? Yep. Let's change these back to 0, 0, 0, 0, 1. It's LR for low res, LRes, no, LR for low res, then sprite priority or clip, and then the order and over border, comma, and then SP on, S on, sprite on. Right. As in back to, yep. Right, so with that done, let's save that. X back, assemble again. And then once this is assembled, we can run it. And you should have that. And it doesn't matter whether you go into exit back to basic and do stuff with the sprite editor, it should all still work. The only thing that wouldn't work was if you did anything with the sprite clipping. If you did anything to change the sprite clipping, because we haven't set any of the clipping values, the sprites would be clipped. But other than that, they should work. Right, now, what I think we should do now is I'm going to go through this and sort of expand it a bit more. Right. And what I'm going to do is write in basic what that instruction actually does. It's basically saying let A equal 0. Now, the A is a register or variable that can only be from 0 to 255. There's no floating points on it or anything, it's just 0 to 255. So it's kind of like a special variable in the fact that they're only 8 bits, so it goes from 0 to 255. So unlike in BASIC where you can have it as a floating point or go to large numbers, you can't with machine code without adding a load more instructions. And then this one would be let xpos equal A. Not A6. Now, xpos is a variable that we've declared in an address in memory, and its address in memory is because it's a label here, and whatever this byte is, this could be a NOP, it could be a ret, it could be a call, it could be anything, but because we want to have it as a variable, we define it as a byte, db, define byte, and then 0, because we want to start at the top left. We could start in the center of the screen, 128 by 96. Let me just show that. A stands for accumulator. Very good. Yes, it does. And you will. Why did that? Ah, I know why. Brain fart moment. We set it up initially at the very beginning. Here. So if we get rid of, not duplicate, if we get rid of those lines and save that, then we're in the center of the screen to start with. Right, and just to prove that we could have had it as a ret, ret. Let's save that. Now, question for the non-programmers that I know will know this, but will the ret be to the right of the center or the left of the center when we assemble it and run it? First one gets a goodie point. Right or left? Well, I was just going to say, ret is C9 in hex, yeah. It's going to be to the right because the center of the screen is 80. So it's almost a quarter of the, well, just over a quarter of the way across the screen. Right, let's put back to DB128. So we've got rid of our let A equals thingy. So this will be let semicolon let A equal string 55. I put in brackets. This is also 85 because 85 is 55 hex. 85 decimal. Right, now what this line does is load let, actually this will be poke, even though I had it as let, but when you're doing load xpos comma a, although it's a poke xpos comma a, it is all, it's or let xpos equal a, it's also poke xpos comma a. So poke string 4000 with comma a. And this poke string 55 to top left of screen. Can't put any more characters in. Right. So that is the, let me save that. That is the 4 pixels that you see in the top left when we start. Show that again. See the 4 pixels in the top left. Over here. That's them. And as you can, it's gone over. Yeah. If you remember from the hex and the decimal and binary that we were doing in the first video, that's what 55 looks like as bits on the screen. Right, now, this next one. In Z80 you have quite a few registers. You've got got a few 8-bit registers. You've got A, B, C, D, E, H, L. But you've also got 2 banks of them, which is like you've got like a exchange where it swaps the banks over. So you got A apostrophe, B apostrophe, C apostrophe, D apostrophe, E apostrophe, H apostrophe, L apostrophe. But you can't really reference them in the code. You have to swap the banks of registers back and forth with an EXX for the HL, the B, C, D, E, H, L, and EX AF, AF swaps the, well, not that, is it? I can't remember which key. 7, there you go. That will swap the A. The F is the flags. The flags are, I'll go into the flags later. Anyway, yeah, it is Control 7. Thank you. Oh yeah, if I press F1 in CSpec, you get to see the registers. You got your AF, BC, DE, HL, and the alternate bank, which is AF, BC, DE, HL, with the apostrophe thing, and we have 2 extra. Right, when you pair the registers together, you get a 16-bit register. You can't really do any 16-bit stuff with AF other than push and pop, because F is a special register because it's got the system flags. And anyway, BC is still the B register and the C register, which the C register is 1A and the B register is 10. But if you combine them together, it is 101A. So BC equals 101A. So you get a 16-bit register, and you can do that with DE and HL, and you get 2 extra 16-bit registers, which are IX and IY, and you can do some pretty good stuff because you can index. You can add an offset to the IX and IY registers when you're reading data. We'll get into that at another point. Probably won't be in this episode. Yes, there's the I and the R, which aren't here, but yeah. And the flags are set up as 8 bits, and we've only got 6 here on show. You got the sign, the 0, the half, nibble, the parity and overflow. The N is, oh, what's the N? Is the N? I forgot what the N is, and carry. Is it negative? No, it's the sign's negative. S is negative. So 0 is positive and 1's negative. Hang on, let me just have a quick look. N is subtract. So if the last instruction was the last operation was a sub, then that flag is set. The N bit is set. So you're missing F3 and F5, which is, so this is bit 7, this is bit 6, this is bit 4, which is the half carry, which is only used with the DAA instruction. Again, we won't go into that for the moment, but it's to for when you're using a byte as 2 numbers in each nibble. So when it goes over 9 on the lower nibble, the H bit will be set. So it's like a half carry, or sometimes called auxiliary carry. And then, so anyway, bit 5 is a copy of bit 5 of the instruction, I think, because it's undocumented flag, and bit 3 is also an undocumented flag, which is why they are not in this window, because you don't really, you've got no access to them from the processor other than push AF and pop AF. So anyway, back to where we were. We've got 16-bit registers, so let's F1 back in, and the 16-bit register can address any of the 64K. So what we're doing with this is telling let HL equal sprites, and that points to HL points to sprites, which is in memory, and our sprites are stored here. So it points HL to the start of the sprites. Right, and then so this one will be let BC equal string 4000. Right, now because we're doing DMA sprites, each sprite is 256 bytes, so that is it's basically 40 string 40 times, which is control B, times 256 plus 0. The reason the C is 0 is because we want to do all 256 bytes of the sprites. So we didn't want to do, if we were only copying half a sprite, it would just be 80 if it's like a 4-bit sprite. So it would just be 128 bytes. But because we want to do all 64 8-bit images, it's 16K's worth. So 1684. So is that clear enough for that bit? Everyone following that? Okay. Let me just get the page back up. Yeah, they do differ from Z80 to Z80, so that's why I'm not talking about 3 and 5. No worries, Pugmoog. We've not really done that much. If you want me to go through, we're just going through, commenting over what the thingies are. So if you go to DMA sprites in your code, Pugmoog, are you up to date with the code, Pugmoog? But anyway, what I'll do is, rather than delaying again, because we'll go through the code anyway, because we're basically commenting on the code and trying to show people what we're doing, and then let A equal 0. What we're doing is we're going through explaining what each instruction does in what we've got so far. And then, so that let A equals 0 is because our function or our subroutine, which is what we're going to our subroutine, which is called DMA sprites, requires three variables to be passed, well, three registers to be passed to it. HL, which holds the address of the sprites that you want to DMA, and BC, which is the amount of sprites that you want to DMA, which is 40 hex sprites times 256 bytes plus 0. And then the A equals 0 because you want to copy them into sprite image 0 onwards. So we want from 0 to sprite 63 to images to have what we're loading in at sprites. Yep, very good point, Gamer Eyes. Now, I'm going to put a comment on the next line. Right. Next reg sets special next registers with either a direct number or A. The A being the register A. Right. And also we have SPR underscore layer underscore control underscore reg has bits. The first one sets the register for layer control. Find in manual as manual. Right, and first bit is the LR. What was the LR? Low res. Low res. And then we have it's Sprite priority. And then we have another 0, which is the border clipping. And then we have 000, which is SLU, if I remember rightly. Let me just check in the manual. I can't remember what page it is, so this may take a little while. Yeah, for anyone else watching, 263 is where they start. And the next register starts at page 266. Right. Here we go. It's on 267. 3/4 of the way down, and it is SLU. All right, and that means the sprites are on the top. Then layer 2 is next, followed by the ULA. Hold on a sec. It's getting in the way. Right. Yep. Yeah, the next registers will be the same because they're basically talking direct to the next hardware. Sprites. Actually, I will put SLU. Oh. Sprites over layer 2 over ULA, and then 0 is sprites over border, and the last one is sprites on. I was going to do active, but I'll just sprites on. So we can turn the sprites off altogether by just setting that last bit to 0. Right, so everyone following that so far? Is that how you want me to detail it? Yeah. You can find where you left it. Right, set sprite index to 0. Let's select. Index to 0. So whenever you write to the sprite registers, actually I'll put it in the comments. Write to registers, e.g. x, y, etc. will write to sprite 0. Right. Let's expos let a equal expos. Actually, to say it right, we should do that actually, shouldn't we? That would be better. Because expos is just an address. Yeah, so that is poke. Right. So that is let a equal p expos, and then let e equal a. Now, if you can see what we're doing here, equal 0. I could have done this. Basically, we're getting X position and we're putting it into the 16-bit register of DE. Right. Because we want to add 32 to it. Because that let DE equal DE plus 32. And Right. And that's to get it over. I'll put it in the comments again. To get 0 to be the start of the visible screen. Because the screen's only 256 by 192, but the sprites go wider, so if you move it 32 pixels over, it'll start at 0, the start of the screen. Yes, I was just going to say I will change it now. Sorry, wrong one. We can do load DE. Now the problem with that is xpos is a byte, as you can see down here. Xpos is only a byte because we only go from because we're only using sorry 0 to 255. Then we don't want to. We're only using a byte, so we can then get rid of that because that does the exact same thing, and we let d equal 0 because d is actually the byte after xpos, which is ypos. So we will do load d comma 0, which will, I need to change that to let d equal peak xpos. So, and then right, this clears the my byte as it's shift 7. It's not part of xpos. As the next byte is ypos. Then let a equal ypos, and I know what you're going to say. A equal peak bracket ypos, but I'm not going to mix the code up because I'm keeping it sort of simple, not interleaving the instructions. Because what I was going to say is we could do it load a comma d before the load d comma 0, and then that would mean that because that's only 4 cycles for that instruction and 1 byte, and this one is a lot more. Is it 13 cycles or something like that? And how many cycles it is offhand, and it's 3 bytes, and it's a lot more than 4 cycles anyway. So, but I want to try and keep it simple rather than having like part of it up here when we're dealing with the y position. And then let a equal a plus 32. And because it's only 8 bits, it would also be like having this if a is greater I can't remember what greater is, which key is greater than t. Right, so if a is greater than 255, then let a equal a minus 256. That keeps a back in the byte, and it'll also set carry as well. So let carry equal 1. I can't put 1 in. Well, but anyway, won't go on. That will also set the carry flag if it goes over 255. Right, let L equal A. We need, actually I'll put it in, I've already commented these ones out, well, explain these, and add sprite. This one would be go sub, add sprite. This uses DE for XPOS, L for YPOS, C for sprite image, B for flip bits, and H for scale, and other things like whether the sprite's relative from the previous like anchor point of sprites. But I'll go into that again at a later date, because you can add sprites together to make bigger sprites. Go sub delay. I guess it's not quite like it's like pause 1, but not quite the same. Just a routine, it's a subroutine for a delay. So I won't put pause 1 there. I'll probably confuse things. Right, and then let A equal peak XPOS. Let E equal A. Yeah, as Matt Davies says, there is no load E comma brackets address. That's why A is called the accumulator, because everything sort of accumulates through A. So a lot of the stuff goes through A to get to where it's destined to. And like all the maths that adding, subtracting, that all goes through A, or there is a 16-bit version of add, which then HL sort of becomes the accumulator, as it were. Anyway, let A equal peak bracket YPOS. Let D equal A. And then subplot. To be pixel expos. You can't split the line. Matt, any chance you can add a split line at the cursor, so you like maybe symbol shift enter puts that on the next line, whatever's after it on the next line, and inserts a line and puts the rest of that line on the next line. Any chance you could add that for next week or whenever, but at some point. Just check to make sure. Yes, exactly right, Gamerize. Basically, you set setting registers with and memory with certain values because your routines, your subroutines, require these registers to be set for when you do like certain things, as you'll see later on when we get into the actual routines themselves. Down here, like when we get into the plot, etc. Actually, as we're just calling that routine, I shall not put it there because I don't want to confuse things, because the call plot is just a call. It's basically just a go sub. It doesn't know. It has no purpose other than just being a go sub. What it does is dependent on what code is at that address. Right. Let BC equal string FB FE. Right. Again, we're setting the BC with a value because this in a bracket C is I don't think, can you read ports in BASIC? In, yeah. It's in it. Let A equal in bracket BC. The reason it is not, well, I'm not totally sure why it's not called in A comma bracket BC, because I'm guessing it's back from, I guess, when it sort of went from 8080 and got reworked as Z80. They left it as in A comma bracket C, I guess for simplicity, to make it easier for the that's not even easier for typing, because it was the instructions were different in 8080. Although they had the same, it was the same instruction, but just the words were different. Anyway, that's another processor, so I won't go into that because I don't want to distract you. Right. Now this bit 0, A is sort of like if A and 1, then if A and 1 this is part of the routine or part of the instruction, because it sets a flag, the 0 flag, depending on what the outcome is of bit 0 in A. So this then becomes, so the line would be, if we change that to brackets so it's a bit clearer, so you know what, A and 1, close brackets, equals, keep doing that for C, but as we're in basics, it's just 1 equal. If it's not 0, so it equals 1, because you're ending it with 1, so it will either be 0 or 1. So if, or actually if we, let's, oh, wrong one, no, wrong one, RT, does not equal 1, not equal 0, not Z, it does not equal 0, then go to not Q. I think that works. Yes, the ports have different different things. They can do all kinds of things. Talk with external hardware, or even hardware that's sort of, well, still external to the CPU. But we're currently talking to the keyboard. If you remember, back in, I think it was the first or the second tutorial, we had the bits for the ports. I think it was the second tutorial actually, wasn't it? I won't go into which key it is there because it's Q. So FBFE is the Q WERTY strip. No Y, sorry. It's just QERT. So TREWQ. And then I've done them that way because that's bit 0, bit 1, bit 2, bit 3, bit 4. Into in A. To A. Actually, if I set A to, yeah, there we go. Yeah, you don't worry as much in BASIC over memory management and managing bits and things like that. But I'm hoping that it sort of, this lesson sort of helps you get an idea for, like, and because I know a lot of you guys already know quite a bit of BASIC or the basics of BASIC, to now realize what this is actually doing. So when you look at other machine code, you will start to be able to pick out what things are doing, because you'll know, oh, that's setting up the A register, and then it's setting up the D and the E. So yeah, it's setting up a 16-bit register, and then it's calling this function, like the plot function or whatever. So it will hopefully help you understand other people's or other small functions when you come to read other people's machine code, or even help you invent your own stuff and take things further with this. Right, and this one is let d equal d minus 1. D was the y pos set above. So the D and E pos, even though we did a call plot, D and E didn't change in our DE routine, because if depending on what was in the plot routine, that could have changed D and E. So, and we'd have to, if like D and E changed, we'd probably put a push DE and a pop DE before and after plot, because we're using D and E down here for the inc D and dec E and inc E. Right. So this is an address for our JR NZ, comma, not Q to jump to. So the not Q doesn't actually do anything. It's just a label reference, well, an address saying to let this JRNZ to know that it's skipping this instruction and going to here. So basically, if Q is pressed, it will do this dec D. Otherwise, it'll just jump past the dec D. Right. And again, let BC. Even when I'm doing LD, I use that as let. DFE, and then let A equal in bracket BC, close bracket, sets A to the GFDSA script of keys, and then if bracket A and 1, close, does not equal 0, then go to not A. And then let D equal D plus 1. Now the reason we do the go to if it's not 0 is because when you read the ports for the keyboard, the bits are inverted. So when it's not 0, it's not pressed. So when it's 1, it's not pressed, and when it's 0, the key's been pressed. Right, and like in BASIC, you'd do if A and 1 equals 0, then let D equal D plus 1. But the problem is you there's no you can't tell it to do the next bit, right? The let d equal d plus 1, because the processor doesn't jump. It always needs to be a go to tell it to go somewhere else, because you can't tell it to just do the next instruction if the Z flag is set or not set. Right. If you see what I mean. Spreadsheet of what to use more. You don't really need a spreadsheet. When you're making a game for the next, you do need to have like a list of banks where you've got your graphics and your music and stuff like that, but obviously that's way later. We will go into that, but we'll go into that a bit later when we've got more stuff going on. Yeah, it requires a different way of thinking, but yeah, you definitely have more control in machine code, and it's a hell of a lot faster. I'm glad it's actually working the way I thought of doing this, because it was, you will either get it or you won't, and hopefully I'm making it clearer. And thanks, Richard Faulkner, for confirming that I have made it clearer. He was wondering why JRNZ. Again, it is because the bit is not 0, so it's a 1. So you want it, if you've not pressed the key, you want it to jump over the bit you're gonna do for the condition being true. So like you want to, when it's true, you want to let d equal d plus 1, but you don't want to do that if you've not pressed the key. So you want to jump over the bit. Right, and then let's, I keep doing the let, B, D, D, F, F, E, and then let A equal in bracket BC. And the good thing about this is, because I'm doing it over and over, you sort of, it should go in A and 2, because this is bit 1 we're testing. And as you can see above, bit 0 is 1, bit 1 is 2, bit 2 is 4, bit 3 is 8, and so on. As you remember from the first tutorial on bits. Control RT or semicolon, symbol shift R and T, for the not equal 0, then go to not O, and then let E equal E minus 1. Alright, I won't comment on the not A and not O, because you know from the first things that they're just labels. They're for the go to, or the JRNZ to go to. So let BC equal string DFF FFE. 6. Right. Let A equal in okay, BC. And then if A and 4, A and 1, sorry. equals 0, then go to not P. Nearly done. Let E equal E plus 1. Let A equal E. Poke expos, comma A. So because we can't do all these extra functions on like the single 8-bit registers, the E, D, C, B, and L and H, we have to put them into the A register and then copy them over to, well, then in the next instruction, or when we need to, depending on how many other instructions you need to do in whatever you're doing. You can then do it with the A register, like poke or adding or subtracting or whatever you're doing. Right, now let BC equal string 7FFE. Let A equal in bracket BC if bracket A and 1. Oh, hang on. Did we put it read or let? Set A to the, yeah. Set A to BMN S sim SP. Of keys. Not equal 0, then go to loop. Oh. Right. Now here, if space was pressed, it's the CPU will go here next. Because it's a routine, doesn't matter the fact it's a routine, it's just because we don't need a ret on it. Because the ret is down here, it just saves doing a call. We could do basically call SPR underscore off and then ret. Hello? Yep, what's up? What's up?
Your screen got back.
Ah, okay, okay. Cheers. I'll sort that. Right. Apparently Currently the screen has gone black. I do not know why. Let me just check OBS. Ah, there you go. It had swapped to another thing. Wrong one. I can't delete them yet. Yeah. For some reason, it must have done a I must have pressed a shortcut key to swap to another scene in OBS, and that's what happened. So yeah, we're all back to normal now. Don't worry. I take it you can see me. Yeah, and we're back. Cool. Phew, how long did nobody can see? Could you hear me? Not really well. Yeah, it was probably using another mic, a different mic. Notto. Yeah, right. Okay. Although the fact that so the Notto is this bit here, and then go to not O, and then next line is dec E, let E equal E minus 1, and then not O is the label for the to tell this go to where to go to. Basically, does everybody know that the labels are just a reference for an address? Did that come out clear enough? Because basically each instruction will have like an address, and this would be dec E address. But because it's not we don't need to call it, we don't need to reference it, we don't do labels for the address. Like now, it is a weird one. This JRNZ would be a JRNZ Notto address, but there would be dec E address would be the same as doing EQU JRNZ Notto plus 2, because there's 2 bytes in the instruction JRNZ Notto. But because we don't need to reference these each individual instruction, we don't need to put a label for each instruction. So it just makes it people understand why we have instruction why we have labels in code. It's just so we can tell things where to go to and go sub and etc. Right, and then after the not O, we have let BC equal DFFE, or string DFFE, and then in A comma bracket C is let A equal in bracket BC. Bit 0 comma A equals if A and 1, and then the JRNZ turns the rest of that instruction into not equals 0, then go to not P. The inc E is let E equal E plus 1, and the not P is let the label that for the go to up here, and then let A load A with E, load A comma E is let A equal E. The load brackets x pos comma A equals poke bracket x pos comma A, and load A comma D equals let A equal D, and then load bracket y pos comma A equals poke y pos comma A. And basically this puts our new x plus, if I can type in, I can't put xpos back. There you go. And this puts our new y position back. And it's a new position because these inc E and dec E and inc D and dec D change the x and y position, and then this bit just puts them back in x and y pos because we're only changing the register E and the D register, so we need to put them back in the position in x pos and y pos. So we need to put it back in memory because otherwise when we do other bits and pieces using the D and E register, it'll get wiped. Right, and then so on our end of game loop, for anyone who joined in after us going back to doing this bit again, this is added from since last week. This was added at the beginning of the show, the end of game loop, and check for space to exit. And then we changed this line. This was ret z jump loop, but we changed them because we wanted to do stuff instead. Right. So if the space wasn't pressed, it will actually, sorry, let's go through these. Let BC equals 7FFE, and in A comma bracket C is let A equal in bracket BC. It reads, sets A to the BNM sim SP row of keys because it reads the input port, which is what the in does, reads an input port, or reads an IO port, which is addressed with BC, which is set, BC is set to 7FE. So this reads port 7FFE and sets A with the value that comes out of the port, well, that it reads from the port. Then we check if bit 0 or tech bit 0 comma A, which is if A and 1, jump NZ comma loop. Would be, so it makes the rest of that instruction. If A and 1 does not equal 0, then go to loop. So if space was pressed, the CPU will go here next, which I've just I added a call SPR off and ret. Right, because it needs to call this routine, and when that returns back to there, it will then quit back to Odin. Yeah, JR and JP. As Matt said, the JR takes 2 bytes and the JP takes 3 bytes. So JR is faster, except when it takes the jump. It's faster to fall through, and it takes 7 cycles to fall through a JR. i.e., if the condition isn't met and it doesn't jump, then it'll only take 7 cycles. Otherwise, it takes 12 cycles. But with the jump, the JP, whether it's a jump NZ, they take 10 instructions, 10 cycles. If he does it, take 10 whether it fails the condition as well. It's not in. Let me check. Yeah, it takes 17 if it fails. if it does the call or JP. Nope, the jump is 10, whether it gets the address or not. Yeah, if the jump is taken, the JP is faster because it still takes 10 cycles. Cycles. I don't know what a tact is, Christian. Unless you call them tacts over there. We call them cycles over here. It's a clock cycle, a CPU cycle, a CPU clock cycle. The CPU gets clocked like every time the crystal does its cycle. Yeah, T-states, yeah. Thank you, Matt. T-states is another word for them. Right. But we don't need to worry about speed for now because we're not doing much and we don't want to get too complicated. Also, we could just not have these instructions in by commenting them out, and that would be faster because it's an optimization that we do with some routines. Like if you want to call something before returning from a routine, you just if you have the instruction or the routine below it, it will just fall through into that routine until it gets to that ret. Otherwise, or what you could do instead of a call and ret, you can do like say there was another routine here, another routine for a ret, right? Then you could just do jump SPR underscore off, and that is quicker than a call SPR off and ret. Right, anyway, that's enough sidetracking. But I'll leave that in for now so you sort of get an idea what it's doing. Right, go sub SPR off and return from calling routine. Oh, actually, it's just return in basic. And because there was no calling routine, in fact, I'll put that in this. There's no calling routine. It returns to Odin. There we go. Right, get rid of that because we've got the call SPR off now. Right. You can next reg in. Yeah, very true. But I don't want to be saying that because if we're using a if they are not using thingy, if they're not using Odin, like if they're saving it as a eventually saving it as a next file, the RST will just do a restart and reset the machine. So anyway, because basically RST0 is like randomize user 0. and RST1 is randomized user 8, and so on. Right, RST2 is randomized user 16, and is randomized user 24, etc., up to RST7, which is randomized user 56. Yeah, until the debug gets better. Right, anyway, next reg. Can you do next reg in BASIC? You can, can't you? Sure, yeah. Is it next reg or is it nreg, or it is next reg in BASIC, isn't it? Reg. Right, so this would be reg SPR select reg 0. Set index to 0. Load B, 128. Let's B equal 128. We want to turn off 128 sprites. Reg SPR underscore pattern underscore reg underscore inc, 0. Turn SPR off, and I put auto increment SPR select. Oh, it's SPR index, isn't it? Right, so it auto increments after it's turned off the sprite, and then so it'll point to the next sprite. Let b dgnz equal is let b equal b minus 1 colon if b does not equal 0, then go to s underscore off loop. Right. Oh, is it next reg in Boreal next build? Okay, no worries, Richard. At least you know anyway. I haven't used Boreal yet. And this is return. Returns to instruction after call. Let A equal D. Get the Y pixel in A. Then calling this routine, it expects D to be the Y pixel you want to plot. and E to be the X pixel you want to plot. Actually, not pixel, coordinate. I should leave it a bit longer after letting go of the shift. Chord. Front plot. Right. Right. A CP, does anyone who doesn't do assembly know what CP is? Nope. Right, basically, yeah, it's compare. Well done, Stuart. It compares the A register with whatever value or register is after the CP. So you could do, like, say you did CP L. So, well, CP space L, not CPL, because CPL is another instruction. CP space 192 is compare 192. So that's what the instruction means. But what it turns out in BASIC is if, and then A is actually if A minus 192. That is sort of what the instruction is doing. It does a fake subtract of one of the number, and so the carry, no carry, would be greater or equal 0. Then return. So, in other words, it subtracts 192 from A, but doesn't set A with the result. It keeps A as what it was. And then sets the carry if it's less than 0, and sets the 0 if it is 0. If it's not 0, the Z flag will be 0. If it is 0, the Z flag will be 1. If it's less than 0, the carry will be set to 1. If it's not less than 0, so if it's 0 or greater than, the carry will be clear, so be no carry. Is that clear enough? Yeah, the ret no carry does the greater than or equal to mass. That's why I put it on a separate line. Because otherwise, if ret P or ret M or ret NZ, you don't know what the rest of the instruction is, of the rest of the if statement is, unless you know what it could have been jump or ret. No worries. Yeah, I was just working out how intricate to go with the carry and stuff, but I needed to. Yeah, no worries, Matt. I'm glad you're here. Don't worry. Trust me. No, I'm glad you're here, providing extra information while I'm waffling on, and also when I go black, when the screen goes black for a while. It always be a minus A, in this case 192. Yeah, basically, I should run it. Let me just save this now that because we should save it periodically anyway. Right. So basically, when we go off screen, that carry is set, and if we're on screen, otherwise, if we didn't have that ret no carry, if we didn't have that ret no carry and still did a pixel add, it could end up writing somewhere we don't want to. So we don't plot anything when it's greater than or equal to 192. So if it's greater than or equal to 192, then we return. So you could also that if could also read as if A is greater than or equal to 192, then return. Because it doesn't actually physically do a subtract 192. So you just see it as if A is greater than 192 when you do the compare 192. But what it's actually doing internally is subtracting, well, fakely subtracting 192 from A, but not storing it back in A. So it's like a fake subtract, but it is actually subtracting it and doing all the setting up the flags, whether you've gone through carry or zero or positive or negative, or whether you whether you've got set your half nibble, your half carry, which is for DAA stuff. Yep. Okay. Glad you understand. I thought I should put that if A is greater than 192, so that makes it easier to understand what you're doing with the compare 192. Like say we had this as a register, like say we had BC set to like 64 and 64. So if it was like you didn't want to go, oh yeah, like Matt's done a thingy for you, comparison. Anyway, now this whole section, it doesn't actually I will do it because the routine is called plot. Right, let HL equal, I'm going to say magically address pixel coordinate for DE, right? Because that pixel add or PXAD will set HL to the screen address of where the pixel at coordinates DE are pointing to. And there's lots of bits that it does. Now, do you want me to go into details with more comments on how it does it, or just are you happy with the magic? Seems like cheating. No, the reason being is it was because the way the screen is organized, you have to do a lot of bit manipulation to get the screen address, and a lot of people over the years have asked me, how do you get something on the screen? It's to help beginners because of the awkward way the screen is laid out. It's a lot easier for people to remember pixel address than it is to remember the bit shifting and in with C7 and stuff like that. So yeah, and then RLCA and a couple of times and lots of messing. So, and then and 7. Oh. There you go. And set AE sets the bit in the E register. Sets the bit of no, it's actually set let A equal pixel. Oh, actually, that should be for E pixel X chord and 7. Yeah, it takes the lower 3 bits of E, which is 0 to 7. Well, it gives you a value of 0 to 7 and the X, well, of the bit to set. So it sets that bit to 1, so you can then OR it to the screen address. Poke. No, sorry, it's let A equal A. Or peak brackets HL. And what that does is it ORs A with the contents of HL, which is was pointing to the screen. And so it essentially sets the pixel that you're going to plot in A register, and then all you have to do then is put that byte back on the screen. Poke brackets HL, comma A. Plots the pixel on screen, and then return. Let's HL equal 3000. Let's HL equal HL minus 1. Let's a big number to count to. Oh, count down from. Let's A equal H. Right, now this one is, does any non-coders know what this does? Okay, I will save. We're nearly done now anyway, Matt. No, this Gamerize, this deck HL load A, comma H or L. What that does is it takes the bits of the high byte of HL and ors in the bits of the low byte of HL. So any bits, if any bits are set, then HL is a number. It's not 0. If all the bits are 0, because you've ored them together, if the when it gets to this, actually, if I this ors in the bits from H to H and H and L to into A and sets the Z flag if all bits are 0. i.e. if HL equals 0, then Z equals 1. Otherwise, Z equals 0. Right, so this JRNZ, so this would be if A equals 0, well, sort of that or L sort of concludes with if A equals 0, yeah, if A equals 0, or I should say if A, I'll put it if A, and then because this JRNZ is not 0, then go to so A is the combination of all the bits in H and L. So if any of them are set in H or any of them are set in L, they'll be set in A. So if it's all clear, if it's not 0, then it'll go to del loop. So that's our instruction in basic, and then return. Right. Let's save that again. Yes, there's no comparison instructions in basic. So you have to usually deck HL, or if you're using BC as the registers, you'll deck BC and then load A, comma B or C. Because A is only 8 bits. Yeah, exactly. It's a good way of detecting any bits. You OR them together, and then that way, like say we've got 4 bits for each. We're going to use, because I haven't got 16 fingers, I'll use 4 bits for each byte. So you got L and H. Right. So say I've got that one and that one. So if I OR them together, I have that. Now if I was doing an AND, Right, so I have that one and that one, and let me see that one. So we're doing an and. This would get rid of that, and you'd end up with and then if we're doing an XOR, go with that. So we're doing an XOR. You all XOR them together. This one, and you'll be end up with these two bits. So that's OR, XOR, and AND. Take your socks off and use your toes. I don't think people want to see my feet. And besides, you need to pay good money to see people's feet, apparently, so I've heard. And you're all getting this for free, so no feet, no toes for you lot. Are you okay, Me7? Have you been following the fact that we're doing machine code and it's only 8 bits, no floats? I missed a post from you. I don't get what your post is. Yeah, I think he's a spammer too. In fact, let's remove that post. Right, so add Sprite. Load A, comma E is let. Oh. Just funny. I don't know. I don't view for your people's feet. Let A equal E. And then we have reg SPR X value reg comma A. Getting worried about these lines myself now. We're getting close, but there's a lot of text in there. Thankfully, not too many lines. It's only 100 odd lines, so about lines altogether. 206 lines. Should be all right. Just proves how solid it is anyway. It's good, it's working. It's a big file. Right. This sets the sprite X value to E, to what was in to what was in E, because it's the low 8 bits. Right. Let A equal L. So this is why we use have different registers having different values coming into this add sprite routine. Right, we have DE being the X position, L being the Y position, C is the sprite, and B is the flip bits, and H is the attributes. because we need to use the A to move all the things around and feed the registers, well, feed the next registers with the values. And then this is reg spr underscore y underscore value underscore reg, comma A. Mike Daly, if you're listening, any chance you can fix the swapping around of the shift key when you press non-shifted keys like delete? As that would be nice. Thank you. If not, no worries. I shall struggle. Load A, comma D is let A equal D, which is the low bit of the X position. And 1. And this is a continuation, or B. Actually, they should be bracketed. So those three instructions is let A equal D and 1 or B. And then reg spr underscore x underscore msb underscore flip underscore reg, comma A. Right, let's save that while it's there. Let A equals C. This sets the sprite y value to del. This sets the sprite. I suppose this should be current sprite, but I'm not going to put the word current in because it will take too many letters. But the current sprite being the one that we set when we do the next reg spr underscore what is it, sprite spr select underscore reg. When we do this, that sets our current sprite index to 0. So when we do these next registers, it sets the current sprite x value, y value. Sets the sprite x msb and flip bits. D, C, let A equals C or string C0, and then reg spr underscore pattern underscore reg, comma A. This sets the sprite pattern and on and OB, over border. Is it over border? No, it's the extra bit for the fifth, the extra byte, isn't it? So I'll plus fifth. Right. And then this one Let A equal H. Reg SPR attributes are reg inc comma A. This sets the sprite attributes and inks index, and I fit it in, yes, and then return, save. Right. Right. Depoke? Is it depoke? You're very tired. No worries. Maybe you should watch it again when it's when you're more awake. Sorry if it's hard for you to concentrate when you're tired. HME7, however you pronounce your name. Hang on, let me just get my cursor back. See Specs pinched it. Let's go a bit, see what I've missed. I don't know what the reason they took you away, Richard. But there's nothing wrong with the Wirral. Which Irish program are you talking about, Tony? Are you getting a buffering wheel of death? Sorry, Bug. Hopefully you'll be able to see what you've bit. We're only commenting on the code, so it's not overly important. So you'll be able to watch it again in a rerun on any bits you've missed. 24 user 23 out of 24 on master. They just lock without typing. Again, not sure what you're talking about. Yeah, it is depoke. Right, okay. Depoke, DMA. Yeah, Wirral's a great place, isn't it, Richard? Depoke, DMA, SRCS, comma, HL. And then another one. Depoke, DMA, len, S, comma, BC. And then let BC equal string 303B. Shift, not control. Out bracket BC comma A. This This sets the sprite image index. Okay, I know what I'll do. I shall. This sets sprite image index. Yes, just fit in. Cool. It outputs to a 16-bit port, an I/O port, which is 303B, which is the sprite index. Right, and all those naked feet. Yeah, port sunlight's quite nice there, isn't it? Very like picturesque with all the houses, the way the houses are. I probably should edit the black bit out, but I don't know whether you could hear bits, and it might seem strange. I'll probably edit it out. Yeah, if I can figure out how to use the editor on YouTube. Right. Anyway, let HL equal DMA code S. Let B equal DMA code len S. And let C equal ZAT underscore DMA underscore data gear underscore port. Right, now I don't think you can do an OTIR in BASIC, but what this does is it basically does out bracket C, comma, bracket peak, brackets HL, colon, where's colon, Z, inc HL, colon, dec B, colon, JRNZ, comma, this instruction. No, LP, I'll call it LP, and then in fact we will do dot LP, and I can go back to why am I doing JP? That should be colon let HL equal HL plus 1, colon let B equal B minus 1. Minus 1. Poop yourself then, I thought it died. Save. If B does not equal 0, then go to dot loop. Yep. Return. And then I won't go into this yet because I need to go over the DMA in total, but that would probably be a bit later on. But just because it's getting a bit late now, it's nearly 5 o'clock, so I'll just finish these up with, this is your Y position. And X position. Ink bin is like loading a load. This is load my SPR dot SPR close code sprites. But that is done when you assemble. It's not done when you're running the basic program. So it's like the ink bin is like saying, I want to include these bytes from this file, all the bytes from this file at sprites from there. So that's what ink bin does. So I think you all know how to use Naughty Ash, yeah. Naughty Ash is cool. Right, so I think what we'll do is I'll do a quick scroll to the top. Right, and save it as well before we forget. And then scroll down. Right, so this is the top bit. Pause here for a couple of seconds so you've got time to pause. And then the next half page. I'll stop here for a sec so you know you can pause it. And then next half page, stop here for a couple of seconds so you can pause it. The next half page so you can stop for a couple of seconds so you can pause it. Next half page and stop so you can pause it as always. And the next half page again for a couple of seconds so you can pause it. And the next half page again so you can pause it. So check your code. Next half page again so you can pause it. And the next half page again so you can pause it. Next half page again so you can pause it. Next half page again so you can pause it. Next half page again pause so you can pause it. Next half page, nearly there. Well, we are there now. It's just, that's it. And back up just in case you didn't have long enough for that page. Here's the pause. And the last line, the sprites ink bin, which is load my sprite, my SPR.SPR code sprites, and that's what it is in basic. So when it assembles it, it basically does load code my sprites into that address. And then anything after that is an address after the end of the sprites plus the file length of my SPR.SPR. LD stops compiling. Ah, right, okay. Let me just. Oh no, yeah, right. Then we should change it to DMA loop. DMA loop. And save. And pause so you can check to make sure. And then voila. And we still have it. Okay, local labels, cool. That would come in handy. Right. In the bit up here, if we do load BC, comma, string 7FFE, who's going to tell me what keys they are? Let's BC equal string 7FE. Yep. In a comma, let A equal in bracket BC. Sets A to key row. That's no, it's not caps, is it? It's space to it's the other end. Yeah, it's B&M sim. Sim space. Yeah. No worries. Right, and then we do bit 2, comma A. If A bracket A and no, is it? It is and, isn't it? What's it? And which and is it in BASIC for binary and? That's binary and, isn't it, in BASIC? Not logic and. Yeah. And 4. Now this changed the next instruction because we're going to do Z, comma. Oh. Equals not, then go subplot. Save that. Oh yeah, need the thingy down. the percentage for integer bits. Thank you. Right. What was it doing? A. Run. Now, as you can see, we have our cursor, and when you press M, it plots a pixel. So now we can draw things. Hey, it works. Cool. Right. Did people find this way of going through the code interesting? Did you learn much from this, or should I continue with this, putting the comments in on things that we had, or should I not put the comments in? Cool, got it. Works for you too, guys. Cool. And Odin didn't crash once. Everything was perfect apart from the black screen, because the screen swapped. What I will do is I will remove the other scenes so that doesn't happen again. I was just playing about with ODS, just trying different scenes. So, like say, I will remove them. Or actually what I'll do is I'll just remove the shortcut keys, because obviously it was taking the keys no matter what screen I was on. So it was, I'll just remove the shortcut keys and keep them in case I need to go full screen on anything. But I'm glad it's helped people understand what the code is actually doing rather than just copying stuff off the screen. You're actually learning what the instructions are doing, and the fact that A is only 8 bits and BC is 16 bits, but it's also B as well as C. So BC is let me just go up to the top of this. Actually, I'll do it at the bottom. If I press it when I'm on CSpec. Right, go down to the bottom. So you've got A equals 0 to 255. And then you've got B, C, D, E, H, L. And then you've got XL, sorry, XH, which we haven't gone into yet, but we will do, don't worry. YL and YH. And there you're, and then you've got actually, if I go back to the beginning, got A, and that should be 8 bits. Right. And then you've got your alternate registers, which is, I don't know what key it is, 7, control 7. A, comma, B, comma, C, comma, D, comma, H. I'm not putting the F's in these because you don't really get to control F like you can with the 8-bit registers. You can control F, but it's, yeah, you have to set carry and complement carry, and then there's the way you set the, there's Z bits, and anyway, I won't go on with that. It's E, sorry, because I was waffling on. H, thingy, comma, L, E. Right, and then we have 16 bits, which equals 0 to 65535. Actually, we shall have 0 string not to string ff, and that's string not to string ff. Right, and you have bc de hl de comma hl comma ix comma iy comma bc de comma hl, and then you have another one which is sp, which is your stack pointer. We won't go into using that bit for a little while. That'll come in at a later date, especially when we need to start changing banks and stuff. What else have we got? Oh yeah. So BC equals B times 256 plus C, and same with HL equals H times 256 plus L, and D equals D times 256 plus E, and also IX equals XH times 256 plus XL, and IY equals YH times 256 plus YL. You can do things like load a comma YL and load YL comma A. You can't do load YL comma YL, or is it Y? Yeah. With L. Because there's some, I can't remember which one it sets, but there's an instruction that means that the next instruction is an IX or an IY instruction, and so what it does is it changes the instruction. Yeah, you can't mix HL with the index registers. Yeah, you can't do. You can do add HL comma DE or add IX comma DE. Can you add IX comma DE? But you can't do add IX comma HL. you can't mix HL with, yeah, hang on. You can't do load YL, L because it's changing the L's to YL. So that's why you can't mix it. Again, I'll get into stuff that you can do with some good stuff you can do with IX and IY when we get around to putting baddies on the screen and stuff. So anyway, I'll just delete that and save. Yeah, the reason for the not being able to do it is the Z80 uses a byte at the beginning of the instruction, which says the next instruction is changes the HL or any H or L to the IX or IY. Yeah, too advanced for now. But if you want to have a play at all, then feel free. But hopefully I've given you enough bits to play with things, like the fact that I know I did it, but the fact that we've done the this bit here where read the keyboard, and if you've pressed the M, then you can sorry, not that bit, this bit. Read the keyboard, and if you press the M, then it'll call a plot, so it'll only plot a pixel when you press M. And you know how to like say you wanted to add a second sprite, right? What you'd do is you'd basically copy load D comma brackets expos2, and then load D comma north, add D comma 32 to get it into the left position, load A comma brackets Y plus 2, add A comma 32, load L comma A, and then load C comma 1, because we'll have sprite 1. Actually, we'll use sprite 0 for now because I've only got one sprite in that set. And then load B comma 0 and load H comma 0, and then call add sprite. Now the thing is, because add sprite does not change BC, HL or DE, we could actually just delete these 3 lines because they're still set from the same, but I'll leave them in there because you're creating a new sprite. So and if we go down to here and do expos2 db 64 ypos2 db 64, save that, we should, fingers crossed, get it to assemble at least, and then have 2 sprites. So then you could then, in the routine after second sprite, you could do things like load a comma bracket x plus 2, and then inc a load bracket x plus 2 comma a. Now you should know what I'm doing by what we've gone through today. The inc a increases by 1, so that is let a equal a plus 1. So let a equal peak bracket x plus 2, and then poke x plus 2 comma a. I'm not sure if you need the brackets on the in basic. The poke, you probably don't. Right, so save that, exit out, assemble. It's much slower because there's lots to type, but it's faster than basic, because if we take this loop out, this delay, well, actually I won't take the delay out, I'll just decrease it down to say 100. Save. And that is going like a pixel at a time. It is scrolling a pixel at a time. It's just moving too fast. So I'll put that back to 3000 anyway. Save it. Right. So I will again pause it on the bit of the sprite bit that we did, so you can pause the screen, or pause the video and type that in if you need to. And then that's all the bit that we added, just from here to here, and then down to the bottom. For the x plus 2 and y plus 2. Yeah, I know the a will auto save. Yep. Or you can do load hl, comma x plus and inc brackets hl. But yes, my load a leaves hl untouched in case you were using it for something. And yes, it is very quick. It may be long-winded when you're typing it, but it is a lot faster when it's running it. Yeah, it does. That's why I put brackets in. It makes it understandable and separates the bits that if you had any maths in there. Right, we shall leave it there because it's 5:30, or 20 past 5. No, it doesn't run your code at 28 megahertz. Well, it runs at default, but we're setting the speed to 3.5 meg at the beginning, the first instruction. if I recall correctly. Here we go. We tell it to slow down to 3.5 meg. So it's running at the slowest speed. Yeah, if I didn't do this, like if I, let's say we comment out this line and save that, assemble, and run. And that's running at 28 megahertz. Could be. Is that now set to? Hang on. Let me set it to 28. Save. Yeah, there you go. It was still running at 3.5. That's now running at 28. No worries. Glad it was. Even though we didn't do much actual coding because the code was already there, I hope it's helped explain an awful lot, so that when we do write more code, you'll have a greater understanding of what it is you're actually typing rather than just copying off the screen. And if you have an understanding of what you're typing, it means you pick it up better and you learn a lot. So good, glad it's helped. Thank you very much. And I won't be doing it next week because it's Christmas. I have a great Christmas, and I shall see you all the week after. Have a good one. Anyone got any questions before I cut off? Anyone got any questions? See you later. And the fact there's no questions means it was all good and well understood. Excellent. Have a good one. See you in the new year. Well, yeah, see you in the new year. I shall now log off. If Sprite gives me the mouse back. Right.